Today we'll solve the server utilization times SQL question. We've taken this question from the book Ace the Data Science Interview by Nick Singh. I'll add the link to the book as well as this question in the description below. So let's start. Amazon Web Services is powered by fleets of servers, and the senior management has requested data-driven solutions to optimize server usage. So we have to write a query that calculates the total time that the fleet of servers was running, and the output should be in the units of full days. The assumptions state that each server might start and stop several times. The total time in which the server fleet is running can be calculated as the sum of each server's uptime. Now we're not thinking about anything right now. Let's just go through all the details that we have. So we have the server utilization table, which has the following columns and their types. We have the server ID, which is an integer. We have the status time, which is a timestamp. And we have a session status, which is a string. Looking at the example input, let's say we have the server ID 1. The time is given as a timestamp, and the session status is start. For the same server ID 1, we have one more time, and the session status is stop. So what I'm assuming at this point is that the uptime, that is the time that server ID 1 was running, is the time from this timestamp, which is the start of the timestamp, to the stop of the timestamp. Also, we are given that the assumption is that each server might start and stop several times. So we have to take into consideration that in our entire table, we might have server ID 1 multiple times, and each time there will be a start and there will be a stop, and the time between the start and the stop would be the uptime of the server. So if we have to imagine it this way, we have server 1, it starts and we just start calculating the time until it stops. We might have another row in the table where server 1 again starts. So we have to calculate the uptime from that start to the next stop time that we have. And the total of all the uptime is what we have to give as the output, which is total uptime in days. If you look at the explanation, it says in the example output, the combined uptime of all the servers from each start to stop totals to 21 full days. Okay, so let's start off. Looking at the table that we have, we just do select all from server utilization, and we see that we have 3 columns. The first column is the server ID. The second column is the session status. That means it started at this time. The third column is status time. Okay, we see that the server ID 1 started at this time and stopped about 2 days later. It's August 2nd is the start and August 4th is the end. Next, we see that the same server 1 stopped on August 13 at 7 p.m. but it started on August 13 at 10 a.m. So it's all a bit confusing right now. So let's just order this table by the status time so that we have a clearer view of what it looks like. I'll just arrange this in a readable format. So I just do an order by the status time. And also let's order by the server ID so that we take into account the first server, then its times, and then the next server, and then its times. So we have server ID and the status ID. If we run this, okay, now it's a bit clearer for us to understand that the server 1 first starts, then stops, then again starts, and then again stops. Similarly, for server 2, we have a start stop, and for server 3, we have start stop, and so on. All we have to do is now is calculate the time from each start to stop plus the time from this start to this stop. So this is for server 1, and we'll have to calculate a sum of all the uptimes for all the servers. Yeah, for all the servers. Now, how do we solve this? So we need to calculate, for an ease of calculation, it would be great if we had another column over here, which had like start times and stop times simultaneously, and the end goal is just stop time minus start time, which would give us the total uptime. But how do we add another column over here which is only the stop times? um, let's say, we add a status time, as in, status time as, let's say, stop time over here. If we do that, we have the same column which has a start and stop. But what we want is, we want this value over here to be in the first row, so that it corresponds to the start of this session, and this would be the end of this session. So it simply take this column over here and do a lead function. So let's try that. If we do a lead of the status time, and we have to use the over clause as well. Okay, perfect. So now what we have done is, we just shifted the last column up by one row, and now what we have is, for the server ID 1, we have the start time, which is the status time, and also the stop time, which is over here. We just shifted one up, so this is good. Although it looks like this is working, what I notice is, if I scroll up a bit, for this corresponding, like for this start value, we have this time, and the corresponding stop time should be this one, which is like 9 hours later. But turns out that this is some random date that has popped up, and we don't exactly know what's happening over here. But what we can do is, when we're applying the lead function, we should group it by the server ID. That means we should shift the columns up corresponding to each server ID, and we should order it by the time as well. I'll just show you first, and let's see how it works. So to group it by the server ID, we use the clause partition by the server ID, and then also order our lag by the status time. Now just see what happens. As soon as we run this code, things seem to start working, as in, for this particular start time, we have this as a stop time, which is correct, like this has been transferred over here. And for this start time, this should be the stop time, which is correct. Now we have it over here as a stop time. And once, for the server ID 1, the last entry is a stop, and this does not have any corresponding another stop time associated to it. So this is working as expected, which is great. Now simply, if you think about it, what we need is just the start time rows, because for this particular start time, this is already the stop time, and as soon as we have this, we are good to go. So why not just try filtering out only the start rows, because this stop row is nothing but, this is just extra for us. So if we just do where session status is equal to start, remember the order of execution and the syntax. We have to put the where clause before the order by clause. So if we do a where session status is equal to start, it should give us only the values where we have the start times, and remove the unnecessary stop values, because we'll not be using them. So as soon as we run this, what we get is something very interesting over here. For this start session, this seems to work, maybe not. I don't remember what we had in the previous run statement, but suddenly we are getting these null values with this, with this start session. And I'll just comment this out just to see what we should be having over here. So let's just note down that the start session, and we have 13th August over here, and the corresponding stop time is null. It should have been some value. So I'll just comment out this start filter and then run it again and check it for August 13. Okay, so for August 13 we have 7 p.m. as a stop time, but when we do a where, we are getting a null as a stop time. So this brings us to a very important concept of order of execution of the SQL queries. So in this particular example that we have, the first thing that will be executed is the from statement. That is, it's getting the data from the server utilization table. Then it will be a where statement, as in it will filter out rows where the session status is equal to start. Then it will do the select statement, which is, in which we are adding the new column as the lead column as well. So it seems that we are just adding a column first from this table and then filtering it out, but on the back end it's actually filtering out values first and then adding a new column, and then at the end it's ordering things by the server ID and the status time. And this order of execution is what is giving us null values over here in the start column. So if I just run this again, yeah, this is not correct for us. So in order to fix this problem, what we can do is we can remove this where clause and save this result that we have into a new table. And to do that, we use the common table expression function that we have in SQL. So we'll create a CTE out of it, common table expression. So let's just call it with stop table as, and this is the syntax. Now with this query, we can access this result that we are seeing over here just by referencing stop table as our own table now. So we have the server utilization table in from the question, and after the operations, the result is now stored in stop table. Just for like a sanity check, if we do a select all from stop table, we should get the same result. So this works. Now that we have created this intermediate table, we can apply our where clause to this one. So just aligning things properly, we have where session status is equal to start. And if I run this, now this looks all good. We have the start times, we have the stop times, and all we need to do is just calculate the difference between the stop time column and the status time column and then add them up. It's very simple. So again, we'll add one more column on the right over here, which would be a difference of these two date times. Simply, we can do a stop time minus status time. Let's see what we get. So we get a new column, which is named column, and we get differences in days. If the difference is in days, if the difference is just hours, like we have over here 9 hours, it will give us hours. Again, days, we have days like 3 days, 4 hours, etc, etc. So it's all mixed up, but the end result that we want is the total uptime in days. So how do we solve this? The first thing that comes to mind is converting everything into seconds. And once we have the result in seconds, we can just convert the seconds into days. So simply, let's just understand how to extract the seconds from the stop time. The approach that I'll be following is I'll use the epoch function, and epoch is nothing but the number of seconds since the year 1970, like 1st January 1970, the number of seconds that have passed up till this time. And to do this, I'll use the function extract epoch from the stop time. As soon as I do that, this is the number of seconds that have passed from 1st January 1970 up till this date. And the thought process behind this extracting epoch is that I'll simply do the number of seconds, like the time up till this minus the time up till this, which will give me the difference in these two times. So the seconds passed up till the stop time minus the seconds passed up till the start time will give me a difference of times. So simply I'll do extract epoch from the stop time minus extract epoch from status time. As soon as I do that, this is the number of seconds which have elapsed between the stop time and the start time. To convert seconds into days, what we can do is we can convert it into minutes first by dividing it by 60, then convert it into hours by again dividing it by 60, and then into days by dividing it by 24. So dividing the entire result, the number of seconds, by 60 times 60 by 24 converts this column into a day. So as soon as I run this, that's what I have. Time elapsed is 2 days, time elapsed is 0.375 days, etc, etc, etc. Now all we want is the sum of this entire column over here. That is our answer. So this is all in days for us. So I'll just do a sum. I'll add this, and we only need one column, so we can just remove this all statement as well. If we run this, we have the sum as 26.08. that is the total time elapsed for all the servers, and the output we see that should be in the units of full days. So we just round this answer as well. So round to like zeroth digit, and it should be called as total uptime days. So as total uptime days, we run this code, we have the answer as 26. Let's just submit. All good, perfect. Thanks for watching, and I hope you liked it.